Hello everyone, I am Talha and today I'm gonna talk about the mole. This is a mathematical chapter of chemistry unlike other chemistry chapters which are basically theoretical. Most of the chapters are theoretical. It is one of those rare chapters that deals with the calculation. In this chapter, we will learn about how to calculate moles, mass, volume, concentration, and how to calculate molecular formula from empirical formula. Now, what is mole? Mole is basically how much particle a substance holds. In other words, we can say for 1 mole there are 6.02 into 10 to the power 23 particles or substances. The value 6.02 into 10 to the power 23 is also known as Avogadro's constant. Before moving on to mathematical solution, we have to know what is the difference between relative atomic mass (RAM) and relative molecular mass or (RMM). Relative atomic mass is basically the mass that each atom has. We have already learned what is the mass number, which is basically the number above of each of the atoms in the periodic table. For example, C12, here the mass is 12. On other hand, the relative molecular mass is the sum of masses of atoms in the molecule. For example, H2O. The RMM would be 18 because the hydrogen's mass is 1. So it has to be multiplied by 2. That would give 2 and we have to add 16 of oxygen. And that will finally give us a molecular mass of 18. Now calculating mole. When the mass is given, we would use this formula. Mole is equals to mass divided by RMM or RAM. For example, a question is given here. How many moles are there in 64 grams of oxygen? We have to always remember the mass has to be converted to G or gram. So we know the molecular formula of oxygen is O2. So 64 divided by 16 into 2. 64 is the mass of oxygen and we are multiplying 16 which is the atom which is the mass number of oxygen. We have to multiply that by 2 because there are 2 oxygen and that would give us an answer of 2. Calculating number of particles. For number of particle, formula for calculating the number of particle is number of mole into Avogadro's constant, which is basically 6.02 into 10 to the power 23. A question is given like how many number of particles are there in zero point 0.5 mole of NaCl or sodium fluoride. We have to always remember the Avogadro's constant is same, always same, regardless of RMM or RAM. Whether we are dealing with relative atomic mass or relative molecular mass, the Avogadro's constant will be always same. So we will multiply zero point 0.5 into 6.02 into 10 to the power 23 into 2. 0.5 is the mole of NaCl and then 6.02 into 10 to the power 23 is the Avogadro's constant. But why are we multiplying the last two? Like why are we multiplying whole value by 2? Because there are two ions. One is Na plus and another one is Cl minus. That is why we have to multiply it with 2 or by 2. For calculating the volume, the formula for calculating it is mole into molar gas volume. For example, what is the mole of 3 dm cube of hydrogen H2? So the formula we will use volume is equal to mole into molar gas. Here it doesn't matter molecule or just one atom, the volume is always constant, like the molar volume, molar gas volume, and it is 24 dm cube or 24,000 cm cube. So we will put 3 in place of volume and then we don't know the mole and we have to find out, and 24 dm cube in place of molar gas volume. And if we calculate that, we would find out that 3 dm cube of H2 gives us 0.16 moles. Again, calculating mole, it is for solution. Prior to that, we have already learned how to calculate mole when the mass is given. Now we will learn how we will calculate mole when concentration or volume, concentration and volume is given. So let's look into this example. Find out the mole of 100 cm cube of 10 mole per dm cube of NaOH or sodium hydroxide. So we just the the solution is very simple. We just like put the values in appropriate places. Like we will put 10 in place of concentration and 100 in place of volume, because in question it is given that 100 cm cube, which is volume, and 10 mole per dm cube, which is concentration. And if we do the calculation, we will get 1 mole. So we can say that 100 cm cube of 10 mole per dm cube sodium hydroxide would give 1 mole of solution. That's all for today. In the next video, we will talk more about the mole calculation and how to find out molecular formula. Till then, take care. Thank you.